Okay, so what we're looking at now is the hydrolysis of an imine back to a carbonyl via h3o+. So basically what that is in organic chemistry terms is we have our imine, got h3o+, it's going to go back into the ketone, or the carbonyl, plus this. Well, first you want to think about what we have. The way I like to do it is kind of just work through it, and eventually you'll learn it. So you're seeing these videos, so I hope that's a good start. So you have h3o+, and you have lone pairs. So what do you think is going to happen? Well, I think this is going to happen right there. So what you just effectively did was protonate this N, and you formed water. So you're going to want to remember that. All right. So now, what do we have here? Well, we have a double bond. We can make a resonance form right there. So you have to check out your products, and you're like, okay, we have a carbonyl. So how could we kind of try to get a carbonyl in here? Well, what we need to do is we need to remove this N, and we need to get maybe a water would help us. So let's just start with it. Even though you might not be able to see how water helps us yet, just hang with me. And we made water here, so we can use it here to attack right there. All right, so now we've got this. Well, water attacked here, but nothing really, water didn't pull off any protons, meaning no hydronium was made. Therefore, we can still use water again. Even though we just used it, we can still use it again. Take an H right there, dump. Now, what we just did was we made h3o+. That's what we just did. Okay, so now we're good here. A lot of students would ask, okay, why couldn't we just protonate this nitrogen before doing this? And the answer that I have is you don't want to have two positive charges on the molecule at the same time. You want to mess with one group and then with another. You don't want to try to do two things at once. So we formed h3o+, so we can use it now. That's the cool thing about these types of mechanisms, is you can use what you made in the next steps. Nitrogen, lone pairs, attack. So now we actually have a good leaving group. This is a fantastic leaving group. So by doing this, we formed water over here when we pulled a proton off of hydronium ion. Now we can have this leave. And when it leaves, it effectively makes this structure, which is one of our products. So we're done with that part. Now we just need to get this part. So let's see what we get when that leaves. Let's take it downstairs. So this is where we're at. Now it's game over from here, basically. You guys know the drill. Right there, we just made water, so we can use that to pull a proton off. And that is the end of it. So now you want to check and make sure you didn't forget any resonance forms.